Okay, this problem here requires a little bit of coordinate geometry to be done. Some algebra also is involved in this problem, and it also involves a skill that we've studied previously in this year, we would have studied last year, as far as finding the equation of a line. And then also we're going to be solving a system of equations in this. So it's kind of a high-level problem, but it's not beyond your capabilities. We've done all this stuff before, so it's a matter of putting it together in this problem. The orthocenter is the intersection of the concurrency of the three perpendicular bisectors of a triangle. Okay, not perpendicular, sorry, altitudes of the triangle. Altitudes, not perpendicular bisectors. So, what I want to do is I want to find an equation for the altitude of each of these sides. And I don't need 3, I just need 2. So it doesn't matter which ones you pick. I'm going to find the altitude coming off of MK. MK is altitude I'm going to find. Okay, so the piece of information I need to get the altitude of MK, or I need the coordinates of MK. All right. I'm also going to need the coordinate of L at some point, so I'm just going to identify the coordinates of all 3 points right away. So to find coordinates, we just establish a horizontal and a vertical direction to get to each point. So if I start at the origin here where the x and y axes intersect, 1, 2, 3 to the right makes M's coordinate for x, 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up is the y coordinate. Looking at point K, K is the origin, so it's 0, 0. And then finally point L, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right, 1, 2, 3, 4, 5 up. So, first thing I need to do is I need to find the equation of a line that is perpendicular to MK that passes through point L. That's what I'm looking for. Okay? And one thing I need you to recall to do this is to the perpendicular slope technique. So if I'm dealing with, let's say the slope of something is equal to A over B, slope is some fraction, the perpendicular slope is going to be minus b over a. Okay, to make a perpendicular slope, you flip the fraction over and you change its sign. I'm looking at line MK, this blue line that I've identified here. I want to find the slope of that segment. I'm simply going to use the slope formula to find the slope of that segment. So the slope of segment MK is going to equal, and that's just using the slope formula. Slope formula, if you recall, this is the slope formula. Second y minus first y over second x minus first x. And it doesn't matter which one's first or second. So I'm going to say point M is the second point, point K is the first point, just to have what point is what. So this is the second x, second y, first x, first y. So in this formula, second y 12 minus first y 0 goes on top. Second x 3 over first x 0 goes on the bottom. So 12 over 3 reduces to 4 over 1. 12 minus 0 of course is 12, 3 minus 0 of course is 3. So if the slope of MK is 4 over 1, the perpendicular slope to MK is going to be the opposite side reciprocal. That's positive 4 over 1. This is going to be negative 1 over 4. The line I'm looking to find the equation of has to pass through point L because an altitude is perpendicular to and it starts at a vertex, goes perpendicular to this opposite side. So we found the perpendicular slope here. Now we just need to figure out how it goes through point L. So the next thing I'm going to do is find the equation of the line that passes through point L, which is 10, 5, that has a slope of negative 1/4. And once you get to this point where you know a slope and a point, you go to y equals mx plus b, and you substitute the m here, the x here, and the y here to figure out b equals. So y is 5, m is negative 1/4, x is 10, and b is what we're looking for. Negative 1/4 times 10 is negative 2.5. If I move the negative 2.5 to the left, it becomes positive 2.5. So B is 7.5. 15 over 2, 7.5, take your pick. All right. So now, if I got my equation, which is y equals negative 1/4 x, I'm going to say plus 7.5. That's the equation of line MK. Oh, I should say the altitude of MK. Let's just say y. Y equals. All right. So that equation there would give me the perpendicular line passing through MK that goes through L. All right. So to plot this, to graph this line, we got slope-intercept method of graphing. If I go up 7.5 on the y-axis, 1, 2, 3, 4, 5, 6, 7.5 will be right about here. That's my y-intercept. That's my starting point. My slope of negative 1/4 tells me every time I go down one space, I go right 4 spaces. 1, 2, 3, 4. So right about there. Go down 1 and right 4. Go right about there. And eventually I'm going to get to L there. So if I were to connect those dots, starting here and going that way, that's the altitude of triangle KML that passes through F. Okay, and just to show you real quick, as far as altitude is concerned, if I were to get a protractor and measure the angle here, it should be a 90-degree angle. And you can see that it's dead on 90 degrees, and that's what an altitude is. So again, it's the coordinate geometry is what we're using there, and that's the technique to do that. Okay, second, I need to find a second altitude, doesn't matter which one I find. All right, I'm going to find the altitude passing through LM. So I'm looking at the line ML. It's the exact same technique I just used a moment ago in the blue here. Slide this over just a smidge. If I start with my slope formula, the slope for line ML, for segment ML, is going to be, I'm going to call this point 2, call this point 1. Again, it doesn't matter which one's which. So for second x, second y, first x, first y. So it's the second y 12 minus the first y 5 over the second x 3 minus the first x 10. So the slope of ML is going to be positive 7 over negative 7, which is negative 1 over 1. If I'm working with perpendiculars, I like a fractional structure, so obviously negative 1 is the right answer, but negative 1 over 1 creates that fraction look, so when I can reciprocate it, it's a little easier to deal with. So keeping it as a fraction is useful here. So the perpendicular slope to segment ML is going to be positive 1 over 1, or positive 1. Once you get to the correct answer, making a non-fraction there, if it can be, is nice. Obviously, negative 1/4 could become a non-fraction, but 1 over 1 can. So the slope that I'm looking for is the slope of 1. It's supposed to pass through point K, which is 0, 0. Okay, and 0, 0 is just a y-intercept. Y-intercept is 0, so I can go through the y equals mx plus b structure again, but it's going to be b equals 0. I'll verify real quick. Y equals mx plus b, y equals 0, m equals 1, x equals 0 plus b, 0 plus b equals 0, so b equals 0. So the equation of the perpendicular to ML that passes through K is y equals 1x. So whatever x is, y is, right? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on, right? So if I were to plot the points there, like so, Let's also start at 0 and go up 1, right 1, up 1, right 1, up 1, right 1. You can use the slope again just the same way. We connect the dots there with a straight line. Like so. And there you go. Now, the next step would be to solve the system of equations, but we've plotted both things, and the answer is sitting right dead on an integer point there, so we can see that they intersect right here. This is the orthocenter, I'll call it point O. So if I wanted to find the coordinates of point O, because I've graphed it and I can see it with my own eyes where it is, I can just count, just like I found the coordinates of K, M, and L, I can find the coordinates of O. So from the origin, I'm going 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4, 5, 6 up. So the orthocenter's coordinates are 6, 6. I think to avoid the whole system of equations thing, if I make a problem up, I'll probably make it come out to a nice integer answer. If it didn't happen that way, let me real quick go to a new page here. Y equals -1/4 x plus 7.5. Y equals 1x. The algebraic way of finding the intersection of those two lines is either substitution or elimination. This says y equals 1x, so I can take this 1x and put it up here in place of this y. So 1x equals -1/4 x plus, I'm going to make this 15 over 2. 7.5 is 15 over 2. Fractional equation, I'd multiply everything by the common denominator, which is 4. 4 times 1x is 4x. 4 times -1/4 x is -1x. 4 times 15 halves. 4 divided by 2 is 2 times 15 is 30. So 4 equals -1x plus 30. Get rid of the fractions. Move the -1x over. So 5x equals 30. Oops. Getting ahead of myself there. And if 5x equals 30, we divide by 5, we get x equals 6. Y equals 1 times x, so y equals 1 times 6, which equals 6 also. So 6 is the order pair. So again, if it ended up, let's say that we did an orthocenter, and let's say the answer ended up like somewhere like here, not right on a pretty integer point like that, then using a little bit of substitution elimination, you find the exact pair of coordinates that way also. I don't know if the book is as nice as I am as far as creating problems. So for me, an orthocenter problem, you're going to get answers looking like this. The book might get you 0.97, 6.34, something like that. So again, using this technique here might be necessary for the book problems.